Hello students, today I am going to discuss with you the oxidation number, means short form ON, oxidation number. It's my third video for the topic of redox reactions. In my first video I told you the old concept of the oxidation and reduction reactions, and in my second video I told you the electron transfer concept. So now today I am going to tell you about what is the oxidation number. Oxidation number is also tells us the oxidation state of an element. So the chemical reactions in which the ionic compounds take part can be decided whether it is a oxidation reaction or a reduction reaction by the concept of electron transfer. So I mean to say that concept of the electron transfer can only explain the reactions in which the ionic compounds take part. So here, what about those compounds in which covalent bonds are formed, or you can say by the electron transfer case we can't explain the oxidation and reduction in the covalent compounds. So take an example here, HCl. Suppose this is HCl, H2 plus Cl2, so it will be 2HCl. From the old concept, a negative part is added to the hydrogen, so it is the case of here hydrogen gets oxidized and Cl2 reduced. So here with the old concept of the oxidation and reduction, but the electron transfer can't explain whether it is an oxidation or a reduction, because here no electron transfer from one side to other. Hydrogen doesn't lose electron and chlorine doesn't gain electron. So how will you define or explain that here in H2 and Cl2 this is a oxidation reaction or it is a reduction reaction? So now come to the electronic structure of S. Suppose this is H and this one is the electronic structure of chlorine. So it is this pair of electron, it is a bonded pair of electron. So here, suppose here, this is hydrogen, both the electrons are for hydrogen, the location of the paired electron pair will be middle in the hydrogen. It will be exactly on the centers. It is the center. It is the center. The location of the bonded electron pair is on the center, but here the location of the bonded electron pair is towards the chlorine. It means the bonded pair electron shifts towards the more electronegative element or more electronegative atom. So here in this way, this chlorine, the electron cloud, the density of the electron compound is much more than hydrogen. So this chlorine will show a delta negative, small negative charge, and this hydrogen will tell us a delta positive charge. So in this case, you can say here a small positive charge on hydrogen and a small. This electron pair, this electron of the hydrogen will be counted towards the, you have to assume, it is the assumption. It is not a case of the transfer of the electron, but it's a assumption. You have to assume that this electron pair, this electron of hydrogen will be calculated, will be counted with the chlorine atom, more electron. So we can say that the bonded electron pair, will be counted towards the more electronegative element or the atom. So that's why to show this, we can't say this is an electron transfer. We have to assume that it is an electron transfer, although it is a shifting of the electron, bonded electron, but we have to assume that it is an electron transfer. So we can say the electron against the electron, chlorine against one electron, and hydrogen lose one electron. So it is a case of this assumption of the transfer of electron can be explained with the help of the oxidation number or the oxidation state of the element. So now I am telling you how will you calculate the oxidation number. Now first of all I will tell you that oxidation number is oxidation state of an element. First thing, so again, the oxidation number is ascertained or can be calculated or can be derived by a set of rules, in which we have to assume that the electron pair of the covalent bond, suppose this is of hydrogen. So the pair of the electron will be counted to the more electronegative element. So in this way, what is this set of rules? So first I told you that the paired electron pair will be counted. First rule, paired covalent bond electron will be counted towards the more electronegative element. But it is very difficult. It is very difficult to remember all the electronegativity of the all elements. So we have decided, we have selected some, we have made some rules to calculate the oxidation number. So there are so many, there is a set of rules by which we can calculate the oxidation number. So what is the first rule? So first rule, the oxidation. So I will not write this. You can write what I am speaking. So here, oxidation number is always expressed or written with the sign of plus or minus. Plus or minus, sign of plus minus. If the oxidation number of an element is 1, so you should write plus 1 or you should write minus 1. In this way, the first rule is that the oxidation number will be written with the sign plus or minus. Second rule. Here, second rule. All the molecule like H2, Cl2, O2, N2, these are the molecules. When the elements present in the molecule like hydrogen, chlorine, O2, N2, etc., the O.N. will be 0. O.N. will be 0. Here, when you will say what is the oxidation number of hydrogen in H2? Then you will say 0. What is the oxidation number of nitrogen in N2? It is 0. It means it is the second rule. Now the third rule. The third rule is that the monoatomic ions, there are so many monoatomic ions like Cl, monoatomic Cl, Br, and you can say hydride H positive. This is also positive. This is also positive. This is magnesium. These are all the monoatomic ions. So in monoatomic ions, the charge on the monoatomic ion is equal to the oxidation number. So here the oxidation number of magnesium is 2. Oxidation number of Br is 1. Am I right? No, I didn't follow the rule first. So you should write here the oxidation number of Mg double positive is at 2 and the oxidation number of the Cl is -1. So always write the oxidation number with the sign of plus and minus. Again, the fourth rule. What about the polyatomic ions? These are the polyatomic ions: CO3, SO4, double negative, or MnO4, 1 negative, and so on. These are the polyatomic ions. What about the algebraic sum? The algebraic sum of all the algebraic sum of the oxidation number of all the atoms present in the ion. What I am saying, listen to me carefully. The algebraic sum of the oxidation number of all the elements present in the ion. Here are MnO. The algebraic sum will equal to the charge of the polyatomic ion. So here what is the oxidation number of SO4? This is -2, MnO4 -1, and so on. Suppose here I say OH, then this is -1. So here I told you about the rule number 4. Rule number 5. The algebraic sum of the oxidation number. The algebraic sum of the oxidation number of the elements present in a compound. Again, listen to me. What I am saying, you can write the algebraic sum of the oxidation number present in a compound. Suppose this is a compound CuSO4 5H2. This is a compound. Suppose this is a NaCl. This is NaCl. This is CaCO3. These are the compounds. Here. So there, copper, sulfur, oxygen. So the algebraic sum of the oxidation number of calcium, carbon, oxygen is 0. So the algebraic sum of the copper, sulfur, the oxidation number of copper, sulfur, oxygen, or H2O, all are is equal to 0. So here, this is the rule. So I have told you about the 5 rules. Now I will tell you about the rule number 6. So I am telling you, it's rule number 6. Here is the 6. Now I am telling you, here these are the 5 rules. To remember, you took S and O and X. Hawks. Speak like hawks. There are 3 rules. There are 3 rules. Three rules that remain. I will tell you that what is the 6th rule. 6th rule is about hydrogen. 6th rule is about hydrogen. Hydrogen has the ON plus 1 in all the cases, like HCl, H2SO4 and HNO3. In this compound, hydrogen acts as the oxidation number will be plus 1, but in the case of hydrides NaH, CaH2, CS2, etc., the oxidation number will be minus 1. So here in hydrides, the ON of hydrogen will be minus 1. So here you should know about the rule number 6 about the hydrogen, that the oxidation number of hydrogen is always plus 1, but in hydrides the oxidation number of hydrogen is minus 1. And now I am telling you about oxygen. So rule number 7. So oxidation. The oxidation number of in oxides, the ON is always minus 2. The oxidation number of oxygen is always minus 2 in oxide and in any other way. So here it is clear. But if there are peroxides, so peroxides are like here Na2O2 or H2O2, S2O2 and Na2O2. Here, so in peroxide, the ON of the for hydrogen will be 1. ON will be 1 for in this oxygen. So I am telling you, the oxidation number is minus 2 for oxygen. Oxygen peroxide, the oxidation number of oxygen will be plus 1. Which one? Hyperoxide. Minus 1, not plus 1. Minus 1 Na2O2 and H2O. And in fourth, C category. If there is a compound OF2 or O2F2, it is a special example. Those are the special example. So here OF2 and O2F2, here the oxidation number in OF2, the oxidation number of oxygen. I am telling about the only oxygen now here in the ABC. So here oxidation will be plus 2 and its O3 is plus 1. In O2F2 it is plus 1, in OF2 it is plus 2. So always remember it whenever it is asked what is the oxidation number of oxygen in OF2, you should tell that plus 2. What is the oxidation number of oxygen in O2F2? It is plus 1. So here in this, now I am taking in our board example D. I have calculated in superoxide, in higher oxides. Suppose it is KO2. Suppose it is KO2, RbO2, rubidium oxide, RbO2. So here it is only minus half. It is only minus half the oxidation. So I have told you the 4 type of the oxidation number of the oxygen. First, in case when oxygen is found as an oxide, then the oxidation number will be -2. When it is peroxide, the oxidation number will be -1. When it is found, the oxygen found in the form of the OF2, then here acts as a positive element, so here positive 1. Here in O2, F2, it is also a positive, acts as a positive element, so here +1. So KO2 and RbO2 here. Can you define that why this oxygen? Because the electronegativity of the fluorine is more than oxygen. So this paired electron, so this bonded paired electron will be counted towards the fluorine. So the oxygen state is here +1 and +2. So in this way, I have told these are the 5 rules, 6 rules, 7 rules, and now I will tell you the 8th rule. What is about X? X means here about the halogen, interhalogen compound. X here, which one is 7 and 8. 8th rule is interhalogen compounds. Interhalogen compounds. What are the interhalogen compounds? So here, this can be I can be IF, I can be ICl, I can be IBr, and then come ClF, ClBr, and now here Br ClBr. Now you can, these are Cl, and again here you can write here bromine fluoride here again, and then you come to the bromine BrCl. So in this case, in normal compounds, the halogen, the oxidation number of halogen is 1 Cl minus, when Br minus, and so here fluorine minus and iodine minus. These are in the form of fluoride, chloride, bromide, and iodine. Then the oxidation number of these halogen will be -1. But in interhalogen compound, here the I is positive and F is negative. So here I +1. Here in this case I. Here Cl +1 and F is always minus. F, the oxidation number of F will always be -1 because it is more electronegative element among the halogens, so it will find. But when it combines with fluorine, so iodine, when iodine combines with fluorine, chlorine and iodine, so iodine will be, the oxidation number of iodine will be +1. When Br found in the form of BrF, so fluorine more electronegative, Br less electronegative, so Br is in +1 and F is -1. Here BrCl, chlorine is more electronegative, so electron will be shift towards the chlorine. So here in this case you should remember about what is the rule among the interhalogen compounds. And again here, when the halogens are found in the form of the halides, fluoride, chloride, bromides, always their oxidation number will be -1. This all about the rules of the oxidation number. By the help of these rules, you can calculate. So in my next video I will give you these several examples of the suppose you want to calculate. Now today I am giving you an example here. Suppose this is MnO4 minus 1. MnO4 minus 1. So calculate the oxidation number of Mn. Calculate the oxidation number of Mn. So manganese. So here what will be? So as I told you, this is a polyatomic ion. So the sum of the atoms present in the polyatomic ion is minus 1. So here the minus 1. M is X and plus. What is the oxidation number of O in the oxide? It is in the oxide form. So there are 4 oxygen and you will write into minus 2. This is the way to calculate. This is the way to calculate the oxidation number. Now you will write here X minus 8 is equal to minus 1 and X is equal to minus 1 plus 8 is equal to the oxidation number is 7. The oxidation number of Mn, oxidation number of Mn is equal to 7. I have calculated the number of oxidation. The oxidation number of manganese Mn is 7. I have written in this form, but the mark will be 0 because I told you the first rule, always write the oxidation number with the sign of plus and minus. So I should have written here plus 1 and plus 7. So it is. So here in this way, these are the oxidation number of. These are the oxidation. This is oxidation number. How will you calculate the oxidation? I will tell you in my coming video. So here today is I have told you about some rules, a set of rules to calculate the oxidation number. I think that you will like my video. And my dear students, I am teaching you like you are studying and you are sitting in a classroom. I have no formality of forming the video, but to give you some information about my teaching, I made a video of this topic. So please like it and share to your other friends so that they can also take a benefit of this video. They can also learn about the redox reaction. So please like and share my video. Thank you very much. One thing I am telling you, my videos are on the YouTube, will be interesting chemistry. With the name of the interesting chemistry, when you search interesting chemistry on your video, you will find my video and go through from the start to end. Thank you very much.